Alright guys, welcome to class. Today we are looking at a system of simultaneous equation and we want to use Enchelon method, the row reduction method, to solve this. So now what we need to do is to change the element here, the first element in row 2 and the first two elements in row 3 to 0. So that is, we want to get something of this nature whereby we transform all this to what? 0. So that we'll be able to get the value of what? Z. So now this is what we do. Please note that throughout our solution, your row 1 will remain constant. So let's write that out. X plus y plus 2z equals to 1. Now I need to eliminate using from our method of simultaneous equation, elimination method. That's what we are using here. So I want to eliminate x. I will subtract this from this because they have the same what? Coefficient 1. So by the time I subtract it, you change that to 0. That's fine. Now the same thing, you subtract this one from this. This is y. You are subtracting 2y from it. You have minus y. And now this is minus z. You are subtracting it from 2z. That will give you plus 3z equals to this side. So you do the same thing. This is minus 2. Subtract it from 1. You have 3. So we'll come down to row 2. We need to change the element of x here to 0. So we'll do the same thing by subtracting it from row 1. Please, mind you, we are not subtracting it from row 2. Row 1 is our pivot. So we are taking this x as our pivot. So now, the x in row 1 is our pivot here. So that x from x, we have what? 0. Now, plus 3y from y, we have minus 2y. Also, z from 2z, we have plus z equals to 5 from 1, we have minus 4. Alright, so now we have another system of simultaneous equation whereby the first element in row 2 and row 3 is now 0. Now we need to change the second element in row 3 to 0. So I'll put an arrow here. I'll call this auxiliary row 3, auxiliary row 3 or auxiliary row. That is, we need to change this to the permanent row. We need to change this. So the same idea, we need to eliminate y here. That is, the 2y that is there, we need to change it to what? 0. So that we have this place to be what? 0. So this is what I'll do. I'll use my elimination method. I'll multiply row 2 by 2 so that row 2 and row 3 will have the same coefficients. This my 0 still comes here. 0. Now, by the time I multiply by 2, if I subtract, I'll have 0. Now, multiply this by 2, you will have 6. 6z. Subtract z from 6z, you have plus 5z equals. Now, multiply this one. You are multiplying this by 2. Don't forget. Okay, for emphasis sake, let's put times 2 here. So that now this becomes 6. You have 6 minus 4. That will give us what? 10. You can see easily that we've gotten an equation whereby we can find the value of z. Divide both side by 5. Divide both side by 5. Now z equals what? Equals 2. Now to get our y, put the value of z in equation 2. Now I told you that this is our auxiliary row. That is, we don't need this row anymore. We don't need it. We don't need it anymore. This is what we are working with now. We are working with this. We are working with this. We've used the times 2. We are working with this. And we are working with this row now, which we already used to find our value of what? Value of z. That is the last one. The 0, 0, 5z equals 10. Now, so we go to row 2 to get our value of y because this one is no longer needed. So let me clean it to avoid confusion. So this is what we have. Now, z equals to, from this place we can get the value of y by putting the value of what? Z. So I have minus y plus 3 into bracket, the value of z, 2 equals to 3. If I do that arithmetic very well, you have minus y equals 6. Then you have it to be equals to 3. You subtract 6 from 3, you have minus 3. Minus cancel minus, so my value of y equals what? 3. Also, to get the value of x, which will be our last step here, to get the value of x, put the value of y and z in row 1, sorry, so that we have x plus the value of y, which is 3, plus 3 times the value of what? Z, which is 2, equals 3. So that let's do the arithmetic now. 3 times 2, that is 3 times 2, that is 6. Sorry, this is, we are using this, sorry about that. This, we are using this row 1, so this will be x plus the value of y, which is 3, then plus 2z, that is the value of z, which will give us 1, which is equal to 1. All right, are we together? So now let's look at it. 2 times 2 will give us 4. 4 plus 3, that is 7. Now subtract 7 from 1 to get the value of what? X. So x equals to 1 minus 7, which will give us x equals to 6. So now we've been able to get the value of x as, sorry, x is minus 6. Sorry, x is minus 6. We've been able to get the value of x as minus 6, y as 3, and z as 2. So that is it. That is how to use Enchelon method to solve a system of simultaneous equation like this. If you can call it a row matrix. So that is how to solve it. The only thing you need to do is to reduce the first, all these elements here to what? To 0, and you have your answer, whereby you'll be able to get your value of z. So that was easy enough. So go through the steps one after the other, and you find it sweet and good. Thank you very much.